In this session, we will understand the analytical data warehouses and in depth about the Hadoop. It's going to be an interesting session. At the same time, this is very easy to understand as well. It's very easy, as I already told you. Now, let's understand the fundamental point. We have considerable amount of big data, which is actually beginning as unstructured sources. On the other side, there is a significant amount of information derived from transactional systems and corporate applications built on relational databases. These structural data sources emanate from the systems of record, including your accounting, the customer resource management systems, and any other specific applications that you have. So, one part of it is unstructured, another part of it is significantly to be considered, which is structured as well. The data is usually traditionally stored in analytical data warehouses or data marts that are typically a subset of larger relational database systems. Remember, now they are very useful in creating context when combined with largely unstructured data sources. So, this is the most important point to understand. They are largely very useful when combined with unstructured data sources. Now it's time for us to get into Hadoop. Hadoop is very famous. It had been famous for a long time now. It is an open source framework for distributed storage and processing large data sets using clusters of commodity hardware. It is designed to handle and to analyze a large volume of data, which include structured and unstructured data, which is making it a very invaluable technology for big data analytics. There are two things that you need to remember when you talk about Hadoop. The first one is Hadoop distributed file system, and the second one is MapReduce. The Hadoop distributed file system, often abbreviated as HDFS, is a distributed file system that allows you for the storage of large files across multiple machines, right? It enables you to store a large content across multiple machines. It provides you the high fault tolerance and also improved data redundancy by replicating data blocks across the cluster. The major point that you need to understand here is it provides you excellent fault tolerance and also it gives you superb data redundancy. And on the other side, MapReduce has to be learned. It is a programming model. We will deal it in detail with an example, and it is going to help you in getting the distributed data processing done. It helps the users to write code that can process the data in parallel across the entire Hadoop cluster. MapReduce, the jobs are used to split and then process and recombine data in a distributed fashion. It is going to be very easy to understand with an example, which I will show you sometime later. But these two are the heart of your Hadoop. One is HDFS, another one is MapReduce. HDFS, as I told you, is Hadoop distributed file system. MapReduce is a programming model. We'll deal about this, and this is very important. Now, there is a question which needs to be answered. Why is HDFS useful in big data and cognitive computing infrastructure? First point is HDFS provide a very clear data service that is well suited for large volumes of data and also high velocity data. It is not just volume of data that is spoken about, but also the velocity of the data is considered. One very important capability of the HDFS is that it speeds the processing of large data volumes and is based on the data that is returned. Most important point again to be considered is the data is written once and then read many times thereafter rather than constant read write of other file systems. So it is a very important approach that HDFS is differing from other approaches, and that's beneficial too. Here data is written only once and read many times. So it's different than the constant read write cycles of other file systems. Please understand this point. HDFS actually works by breaking large files into smaller pieces called blocks. Remember, this is a very important point. HDFS works by breaking huge volume of files into smaller pieces called blocks. Now, name nodes is the next thing that you need to understand. In the picture, you can see that there is a name node, there is a data node. We need to understand what is all this. First, let's start with name node. The name node is going to help you in keeping track of where data is physically stored in the cluster. That's it. It is going to help you in tracking where the data is physically stored in the cluster. And to maintain this, to know this, the name node needs to understand which blocks on data nodes make up the complete file. That's a very important aspect. The name node also manages all the access files, all the access to the files, which include read, write, creates, deletion, and replication of data blocks on the data nodes. This is a very important point, very important feature that name node brings you on the table. Also, the name node has the most important responsibility of telling data nodes if there is anything for them to do. So it is the director, it is going to tell very clearly the data node that if they have something to do. So please understand, the name node is going to manage the complete file access, which includes the read, write, create, deletion, and even replication. Also, name node is managing the data node's action. It is going to direct the data node for doing something. So this is a very important aspect of name node, and that's to be understood. And coming to the map reduce, this is something that we need to understand through some simple example. Map reduce is very interesting concept. I am taking some reference here. This is a very common reference that comes out in the internet as well. Sam's mother believed that an apple a day keeps a doctor away. Sam's mother clearly trusted that an apple a day keeps a doctor away. Now, the point is, Sam thought of drinking the apple. Yes, he wanted to make it drinkable and he used a knife to cut the apple and he wanted to make it a juice. So what he did, he took the knife, he has to cut it now and he has to grind it and he will get it as an apple juice. That's it. Now coming to the next point. Sam applied his invention to all the fruits he could find in the fruit basket that he had at home. So he had apple, he had orange, he had pomegranate, he had many other fruits. He cut them into pieces and then he reduced it to small pieces. He then mixed it, he grinded it properly, and then he had the juice. So Sam applied the simple principle of cutting apple into pieces and then making it juice and drinking it. Similarly, he tried it for other fruits as well. Now, after a few years, say about 20 years, Sam got his first job in the juice company. Yes, he has a great talent in making juices and now he has got a job in juice company. Now it's just not one basket of fruits which he has to convert as juice. Now he has got a whole container of fruits which has to be converted. Also, they produce a list of juice types separately. This company has to sell it separately. It's going to be apple juice, it's going to be orange juice, it's going to be mango juice. But Sam has only one knife and one mixer grinder. That's it. So Sam has to now really think very nice about it and he has to get a solution where one container full of fruits have to be cut, have to be converted to juice, and they have to be bottled separately, saying that this is apple juice, this is orange juice, this is mango juice, etc. Now we have large data, we have list of values that we know what has to be output, but I have got only one knife and only one instrument which can help me. Now he has implemented a parallel version of his innovation. Now what he does, each input to a map is a list of key value pairs. It's a very simple thing. Apples, orange, and say pineapple. Now, what he does is he's taking a basket and the basket has got multiple fruits. He will identify apples, he will identify oranges, he will identify, say, pomegranates or whatever, and he will cut them and separate them properly. He will isolate apple, orange, and pomegranate. Then he will do the same thing for all the five baskets. Now, all the five baskets will have apples available, all the five baskets will have oranges available, all the five baskets will have pomegranates or any other fruit available, but they'll be grouped properly. Now it's very easy for him to collect all the apples together, grind it once, pack it as apple juice. All the oranges collected, group it, grind it, and orange juice is ready. Similarly, mango juice or any other juice for that matter will be properly available for you. Now it is reduced to a list of values easily. Now I have five baskets. Five baskets had three fruits each. Each of these baskets had three different types of fruits. Identify the fruits, cut them and keep it separately for each of the five boxes. Now mix all the fruits of similar type together, grind it, get the bottle ready. That's it. This is called the map reduce. Very simple. The idea of map reduce is very useful in intensive computing. It's very, very important. So it is very important to understand that you need to have a proper setup available there to identify the fruits, to cut the fruits, to collate them all together based on the types, and then you need to grind it. So you need to have a proper setup available, infrastructure available for you to go ahead with it. The knife is called mapper, the blender is called reducer, and it's very, very important not to have any side effects as well. You should not have any residue left after use as well. This is one important point you need to consider. I have very big data. I am splitting it. Now I do a grep. I find the matches. I do a concatenation again. I match it. That's it. This is a very simple way of doing it. Now we will see a very simple example here. This will make you understand things very easily. Now you can see how MapReduce works. This is very simple and the count will get automatically increased and the grouping will happen automatically. You are going to reduce a large volume of data properly using this MapReduce and you will group them appropriately at the end of it. This is the practical way of understanding how MapReduce works. I hope it was useful and easy for you to understand and try it out. If you have any questions, let us know. I'll be very happy to answer. I'll come back to you in the next session and it's going to be interesting as well. Thank you.